This is a clone of the Mostortion that I just built. I made a detailed video of the process. If you're interested, the link is in the description. You will find sound samples and a component shootout there. As you may have noticed, it's missing the enclosure. So in this video, I will document how I go from this to something like this. So it's mainly going to be about drilling and painting. I will document my approach to tailoring the enclosure for this circuit. In the end, I intend to play the finished pedal, but keep in mind that this time the sound is not the focus of the story. It's this, the Hammond 1550M enclosure I'm going to use. I could probably fit it in a smaller case, but there are 6 knobs to place, and they'd be too cramped to tweak comfortably. Let's start from listing what else I need besides the enclosure. That would be knobs, a power socket, input and output jack sockets, a bypass indicator diode, and a bypass foot switch. Here are the knobs. The original Mostortion used green and yellow, and that's what I'm going for. Yellow knobs on a green case. As I said, there are 6 knobs: volume, drive, and 3-tone controls, bass, mids, and treble, and a diode selector which uses a rotary switch. The original didn't have a diode switch, so I'm going to use a different knob color for it, both to indicate that it's a different kind of controller, a switch rather than a potentiometer, and that it's a modification. I'm wavering between white and black. Black is in the original's palette, but it stands out too much next to the yellow. I think I will see how it looks on the painted case. Now, let's look at the power jack. This is standard Boss-style DC power socket. Practically, it's the only option I have. There are many metal variants of this type of socket, like this one, which I quite like, but the standard pedal power jack polarity is minus on tip and plus on ring, which is kind of backwards. And metal sockets connect the ring to the enclosure, which should be grounded, but that would short the circuit. The polarity starts to make sense when you deal with an old-style germanium FAS, where ground is positive. In that case, I would use the metal socket, which would also ground the enclosure. As you can see, there are 3 pins. The 3rd pin is used to disconnect the battery when you slide the connector in, but I'm not going to make a battery connection, since I almost never use batteries. Here are the input and output jacks I'm going to use. These are called amp-style jacks. I prefer this kind over the open jacks, which look like this. Amp-style jacks take up more space in the enclosure, but I like the soft action. As you can see, these have pins for PCB mount. The supply of quality jacks of this kind is sometimes limited around here, so I often grab PCB ones, even though I don't use PCBs. It's not that different to solder in the end. And here's a 3-pole double-throw foot switch for true bypass. Frankly, I feel somewhat silly for using it, which is because I don't think I've ever touched any of my pedals with my foot. I always operate them on my desk with my hands, so it feels awkward to use a foot switch, and calling the effect a pedal. I feel I should just use lever switches, yet I stick to foot switches as a nod to the roots of pedal tradition, I guess. I do, however, prefer soft click types, which are easier to switch by hand. Now I need to figure out the component layout, what goes where. I'll start with the power jack. It goes on the back. No question about it. Some pedals have the power jack mounted on the side, which I find quite inconvenient. Then the bypass switch goes on the bottom of the front. That's where you'd expect it to be. For the input and output jacks, there are 2 mounting styles. Put them in the back, next to the power jack, or on the sides. The backside is convenient when you have many pedals in a chain. It saves space. I mean it would if all pedals in the chain had jacks on the back, which is rarely the case. The disadvantage of the back mount is the wiring situation. You need to run a wire from the input to the foot switch and then from the foot switch to the output. With the jacks on the back and the foot switch on the front, the wires have to go all the way through the case. For a high gain effect like this one, I'd rather keep the input wire as short as possible to avoid feedback loop. So I'd like to place the input jack right next to the bypass switch. Alternatively, I could use a shielded wire for the input, but I think I'll just go for the side-mounted jacks. So it would look like this. Then I would place the board like this, so the input wire, the white one, is very close to the switch. Note that the case is upside down now, because I'd like to mount the board in such a way that I can see the components when I remove the back plate. The output wire, the orange one, is connected to the volume pot, so it will go above the output jack. Then the rotary switch will go above the input jack, with the drive pot in between, under the board, and the tone control pots will go above the board. Then the front layout would look like this. I also need to place the fizzle switch, which is on a hot signal path. So, to keep its wires short, I'd place it in between the mids and bass knobs. It would make more sense next to the treble knob, but I'd keep it on a short leash. I think I can start drilling. I'll begin with the input and output jacks. Here's my drilling equipment. This kind of step drill bit is indispensable for this job. Maybe someday I'll get a drill guide, but for now I drill by hand, so everything ends up a little off, but I can live with that. And there we go. Now I can mount the jacks and see how close I can place the foot switch to the input jack. Then, with the foot switch and the jacks inside the case, I can see how close I can place the main board and whether I can fit the smaller board and the rotary switch next to it. So I place the switch module, leaving enough open space for a potentiometer above it. Let's check again how it fits. I'm going to place the drive and volume controls in line with the rotary switch. Now I've drilled the holes for the tone section, and the lever switch will go below, in between the bass and mids knobs, just above the main board. The power jack will go in between the pots, so it will be easier to access inside the case. Finally, I need to place the bypass diode. There's room between the output jack and the foot switch. Now that the layout is settled, I can trim the wires between the board and the pots and switches, which I intentionally made a bit long when assembling the circuit, and mount everything inside the case to make sure it fits. You might have noticed that some pots have a plastic cover on the back, and some don't. The cover is great if the pot goes beneath the board, as it prevents shorts. I use Alpha-branded pots. A couple of years ago they would always come with the cover. Now it's a bit of a lottery. Sometimes they do, mostly they don't. You can buy covers separately, but they're not easy to find locally, and I didn't wrap my head around to do so yet. In this build, 2 pots go beneath the board. One happens to have the cover, the other one doesn't. So I'm going to use a silicone bumper pad and stick it on the back of the pot to prevent it from shorting the circuit. Such bumpers are used for furniture. They are cheap and very easy to find. Now I can proceed to paint the enclosure. I'm going to use a spray can paint, which can be actually quite durable if you do it right. First thing to keep in mind is that the surface of this enclosure is oxidized. When you touch it, it feels like a chalkboard. Every new aluminium enclosure looks like this. So I need to sand it before painting. And here's how it looks after using sandpaper and cleaning it with isopropanol. Now I could just cover it with a clear coat, which would preserve this glittering look. but I'm going for the bright green, like the original. So I will start by applying the primer. It's best to use a dedicated primer for aluminium, like this one, which, thanks to the automotive industry, isn't such a niche product, because people like to paint their alloy wheels. And here's the enclosure painted with the primer. It dries quite fast. I should be able to apply the paint after an hour or so. I've got this generic bright green RAL 6018 paint. I think it should fit the early 90s mood. So I applied several layers, letting it dry a bit between coats. Now I need to let it dry for at least a day. A day and a half have passed. I hope it's dry enough to do control labeling. I have seen different approaches to this in DIY or handmade pedals. Stickers, decals, etching, rubber stamps. I believe Analog Mic and JHS used rubber stamps at some point. As for me, I just use markers to handwrite the labels. I don't really want to spend too much time on decorating. I'd rather spend it on playing with the sound. Then I usually fill all the space with knobs and switches, so there's not much left for the artwork anyway. To prevent the labels from fading, I need to write them before applying the clear coat. The difficult part is that I only get one try. There's no good way to remove a marker trace. Not from fresh paint. If I make a mistake, I'll need to remove the whole paint and start over with sandpaper and primer. I'll start with the top row. Now I'm going to mark the rotary switch positions. And label the remaining knobs. Now I need to come up with a name. You cannot copyright a circuit, but the name is protected. Of course I'm making one pedal for myself, so nobody cares, but let's play by the rules. The chip is described as an operational amplifier with MOSFET input and CMOS output. So the MOS in Mostortion comes from the input stage. Let's draw from the output stage then. How about CMOS drive? It doesn't seem to be taken. I use the backplate for notes. Now I will let the marker paint dry for a couple of hours and then apply the clear coat. Marker writing can dissolve in clear coat, so it's crucial to let it dry first and then apply several thin coats, letting each one dry a bit. Then I will need to let it dry for a day or two before mounting the circuit. The paint will actually take a long time to fully cure. It can be a bit soft and fragile for a month or two. 2 days have passed. The enclosure is covered with a rather thick layer of clear coat. It's cured enough to assemble the pedal and finish the wiring. Because the power and input-output jacks don't make contact with the enclosure, I need another contact point to ground it. I could get a special washer for the input jack, if I care to get one. Or I could solder a wire to the back of a pot, but I'm a bit reluctant to do so. What I'm going to do is solder a wire to the foot switch washer. It's a tooth lock washer, and I reckon it should make a solid connection. Also, I have 3 pins on the foot switch that I need to ground, so I can use the same wire to connect them. I added a small board with a 2K resistor in series with a 10K pot, so I'll be able to adjust the bypass LED brightness. I'll use a yellow diode to match the color of the knobs and mount it in this metal bezel. The LED holder and power connector are the only components with nuts inside the case, so I mounted them first. Moving on to the jacks. and the foot switch. Now I just need to mount the circuit and connect it to the power jack and the bypass switch. Let's check if it works before closing the case. And it works alright. Case closed. Knobs fixed. Now I just need to decide on the extra knob color. White or black. And it's going to be black. So it's done. I'm now going to play it. Check how controllers work. Then I'm going to end the video. For the record, I'm connecting directly to the sound card. There's no guitar amp involved in the sound check.